All right, in this short video, I'm going to talk about parallel lines. Parallel lines are lines that are like train tracks. They are side by side, but they never touch. No matter how far I extend them, they will never ever touch. That is what parallel lines are. I can think of them as being the two L's in parallel. That's how I remember what parallel means. So parallel lines are two lines that never touch. They could be like this. They're never touching. Those are parallel lines. These are parallel lines. These are parallel lines. These are parallel lines. These are all examples of parallel lines. Now, what do they have in common? Parallel lines have the same slope. So do you see that here's a graph and this line has a certain slope to it, okay? Now if I were to write a parallel line to this line, whatever line I wrote, there's lots of parallel lines I could write, but they all have the same slope. So let's say that this line right here in slope-intercept form was y equals 2x. Let's see, it crosses here at a negative place. Let's say it crosses at -1, -2. So this line has an equation of y equals 2x minus 2. The slope of this line is 2. Since the slope of all of these lines are the same, that makes them parallel. So this line here also has to be y equals 2x. Let's see, where's it go through? It looks like it goes through maybe a half. So it's 2x plus 1/2. That's where the b is right here. Up here, this line also has a slope of 2, because do you see that they're parallel? So this is y equals 2x. Let's say up here is 5. So it would be plus 5. And then up here, this also has a slope of 2. So it's y equals 2x plus, let's say, 5, 6, 7. 7. So y equals 2x plus 7. So do you see that all of these lines, the m is the same for all of them? Okay? So because the m is the same for all of them, they are parallel lines. If I instead had a line that had a different slope, let's say I had another line that had a slope of maybe 1, do you see that since, and let's say it goes through, I don't know, 3 here. Do you see that because the slope of this line is only 1 instead of 2, it's slanted a little bit downwards? And since the slant of this line is a little bit less, at some point it's going to run into this other steeper line. So if two lines have slopes that are even just slightly off, at some point one of them will run into the other. And that's why parallel lines need to have the exact same slopes. All right, so the last thing that I want to talk about parallel lines is if two lines have not just the same slope, but the same y-intercept, then they're not parallel lines, they're actually the same line. So let's say this is y equals 2x plus, let's say it goes through 1 right here. This is 2x, because, or the slope is 2, okay? And it goes through 1, so it's 2x plus 1. Let's say this other line down here was parallel, so let's say it's y equals 2x, same slope, but minus, I don't know, 1, 2, minus 3. So it's down here, okay? These are parallel lines. They have the same slope. But do you see that they have different y-intercepts? What if a line had the same slope and the same y-intercept? Well, if I were to draw another line that had a slope of 2 and also a y-intercept of 1, do you see that it would be on top of this other line completely? Since these two lines are completely on top of each other, we actually don't consider these to be separate lines. We consider them to be the same line. And so we don't call them parallel lines, we just call them the same line. So in order for two lines to be parallel, they need to have the same m, the same slope, but they have to have different y-intercepts. So they're at least separated like train tracks. Thanks.